All right, let's get right into it. You know that feeling, right? You flip to the back of the exam paper and see one of those massive 5-mark questions just staring back at you. Well, today, we're going to take one of those questions and we're going to completely dismantle it, piece by piece, so you know exactly how to walk away with every single mark. And here it is. This is question 21 from a GCSE higher paper. It's a solid cuboid problem, it's worth a whopping 5 marks, and to make things even more interesting, it's on a non-calculator paper. This isn't just a geometry question, it's a test of your pure algebra skills, a real classic challenge. Okay, so, first things first, before we even think about picking up a pen, we have to play detective. We need to look at this question and pull out every single clue the examiner has given us. Trust me, nothing is there by accident. So, here are all the pieces of our puzzle, laid out nice and clear. We've got the shape, a cuboid. We know its volume, its total surface area, and its length. And then there's this really important condition. The width has to be bigger than the height. Our mission? To use all these clues to find the height. Now, here's the really cool part. We're not going in blind. We're actually going to use the official mark scheme as our roadmap. Think of it like a blueprint that shows us the exact 5 steps we need to take to build a perfect full mark answer. See, it's a 5-step journey. We start by making an equation for the volume. That's mark 1. Then, we make one for the surface area, mark 2. Then, we get clever and combine them to create a quadratic equation. That's 3. We solve it for mark 4. And finally, we pick the right answer for the 5th and final mark. Let's do it. All right, let's get our hands dirty and start banking some of these marks. This first part is all about translation, taking the information from the question and turning it into the language of algebra. We need 2 equations.
We'll start with the easier one, the volume. We know the formula, length times width times height. So we just plug in what we know. 300 equals 20 times W times H. A quick bit of rearranging, divide both sides by 20, and we've got this lovely simple little equation. W times H equals 15.
And check this out. We go look at our blueprint, the mark scheme, and what does it say? P1 for forming an equation using the volume. Just like that, we've got our first process mark. We are officially on the scoreboard.
Okay, 1 down, 1 to go. Now for the surface area. The formula is a bit more involved. It's 2 times the area of the front plus the top plus the side. So 370 equals 2 times the whole lot. Again, let's simplify by dividing everything by 2. That gives us our second key equation. 185 equals 20W plus 20H plus WH.
Let's go back to our trusty mark scheme. And yep, there it is, clear as day. A second P1 process mark just for setting up that surface area equation. That's 2 marks in the bag. The problem is now officially set up.
Okay, so we've got 2 equations and 2 things we don't know, W and H. This is where we get to the real heart of the problem. We need to solve these 2 things at the same time. This is where the real algebra begins. So, how do we do that? Well, this is the aha moment of the question. We're going to use a technique called substitution. We take our simplest equation, that nice W equals 15, and we just rearrange it. Let's make it W equals 15 over H. Now we can take this expression for W and plug it straight into our bigger, messier surface area equation.
So when we do that, here's what we get. Now, I know, it looks a little ugly with that fraction in there, but we can fix that. The trick is to multiply times every single term by h. That gets rid of the fraction. Then all we have to do is shuffle everything over to one side and boom, we have a perfect quadratic equation. 2h squared minus 17h plus 30 equals 0.
And what does our blueprint say about this moment? It awards a third P1 mark for eliminating a variable and creating a quadratic. We are now 3 marks down, with just 2 to go.
Now we just have to solve this thing. And remember, no calculator, so we need to factor it. We're looking for 2 numbers that multiply to make 60, that's the 2 times 30, and add up to negative 17. A little bit of thinking, and we get negative 5 and negative 12. Once we factor it all out, we get 2 possible answers for the height. H could be 2.5, or H could be 6.
And for that beautiful piece of algebraic work, the mark scheme gives us our 4th P1 process mark. We've got 4 out of 5. We are so close. Just that final accuracy mark left to grab.
But hang on a second. We have 2 possible answers. How can that be? A cuboid can only have 1 height, right? To figure out which one is correct, we have to go all the way back to the question and look for that one last clue we haven't used yet.
So, this is the final hurdle. Is the height 2.5 or is it 6? The examiner left us a condition, a rule that the answer has to follow. Do you remember what it was?
That final clue was simple. The width must be greater than the height. So let's test our two options. Scenario 1, if the height, h, is 2.5, then the width, which is 15 divided by h, must be 6. Is 6 greater than 2.5? Yes, it absolutely is, so that one works. Now, scenario 2. If the height is 6, then the width is 2.5. Is 2.5 greater than 6? No way, so that solution is impossible.
And just like that, the puzzle is solved. The only possible value for the height that works with every single piece of information in the question is 2.5.
For that final step, our blueprint confirms it. We get an A1, or accuracy mark, for the answer 2.5. But look at that note. It's really important. You only get the mark if all your working is there. You can't just guess. And with that, we have officially collected all 5 marks. So let's just pause and zoom out for a second. What did we actually learn here? What was the strategy that took us from a pretty intimidating question to a perfect solution?
The key was to not be intimidated. Instead of seeing a big 5-mark problem, we saw it as 5 small 1-mark steps. We meticulously pulled out every piece of information, we applied the formulas we knew, we used that key substitution trick, and, this is the most important part, we remembered to use that final condition to pick the correct answer. That's the blueprint for success. This whole approach just turns a scary question into a simple checklist. So I'll leave you with this question to think about. How can thinking like an examiner, knowing exactly what they're looking for at every step, completely change how you tackle the next big question you face?